All right, so what we said is that electrons live in these orbitals. And so what we're going to take a look at next is how these electrons fill these orbitals, and what we can think of them as kind of like empty houses. Which ones are they going to take up? When are they going to double up? That kind of thing. So electrons fill orbitals from lowest energy to highest energy. Right, so they'll fill up all the lower energy ones, then go towards the higher energy ones. So let's take a look at different elements. And what we're talking about here is if we had the atom just totally by itself. So hydrogen first, it only has one electron. And so we can draw two different kind of diagrams or configuration of this. We can write out what's called the electron configuration. Or we can have what's known as the orbital diagram. And you need to be familiar with both of them, but overall they say pretty much the same thing. So if we think about our lowest energy orbital, that'll be the 1s orbital. So the 1s orbital, the 1 stands for that letter n. So n is equal to 1 here. And then our s is our L. And in this case, our L is equal to 0. And since we only have one electron, we call this 1s1, where this one is the number of electrons in that particular orbital or in those orbitals. And then on the orbital diagram, we're actually going to explicitly draw out the electrons. So we'll draw a line under it. We'll call that the 1s orbital. And then we're going to put an electron there. So when we draw these electrons, we draw them as half hook arrows. And generally, you draw the first one pointing up. Then we can think about helium. Helium also very simple. We have 2 electrons. So in this case, we're going to do 1s, and remember that there can be up to 2 electrons per orbital. So both of these electrons are going to go into the 1s orbital. So we call that 1s2. And same thing for the electron configuration. Now we can draw one pointing up, and then remember they have to have opposite spins if they're in the same orbital. So we're going to put the other one pointing down. Next atom we can take a look at is lithium. It's got 3 electrons. So now we'll go for the 1s2. So we used up 2 electrons. We can't fit any more. We have to go on to our next highest one, which will be the 2s orbital. Right now, n is equal to 2. But our our L is still equal to 0. And in this case, we only have 1 electron left. So we'll do 1s or 2s1. And of course, we can draw the diagram for this. So we'll have 2 electrons in the 1s orbital, and then we'll only have 1 electron in the 2s orbital. All right, finally, we've got oxygen. We've got 8 electrons here. So the orbital diagram will here go 1s2, and then we'll fill in the 2s2. So now we've used up 4 electrons. So we only have 4 more remaining, and these will all go in the 2p orbital. So in this case, 2p4, right? Here, n is equal to 2. L is equal to 1, right? That's why we have the p orbital. And we can draw the configurations as well. So we have 2 electrons in the 1s orbital, 2 electrons in the 2s orbital. And then when we think about the 2p orbital, remember that there's 3 2p orbitals. And now the way that we fill these electrons is very important. So first, every orbital gets 1 of them. So there's 1, there's 2, and there's 3. And they have to be pointing in the same direction. So every orbital gets 1 before doubling up. And they all need to point in the same direction. Right, so we've used up, let's see, that's 7 of our electrons. So now we need to put an 8th. Now that each one of these orbitals have 1, now we need to start doubling up. So our 8th electron will be pointing down here. And so that's our electron configuration and orbital diagram for these atoms. Now, all of this might sound very complex, but if you have a periodic table, it couldn't be simpler, right? So all we're going to do is read the periodic table like a book. Right, so we're going to read left to right, line by line. And then we're just going to remember a couple of things from our periodic table. Remember that each row is our n. So there's our n equals 1, n equals 2. Remember that over here we have our S block. And then that over here is our P block. With helium being a bit of a weirdo and being part of the S block more than the P block. And so if we think about oxygen again, right, let's redo oxygen. So oxygen's right over here, and we're going to figure it out, right? So we're just going to read the periodic table like a book, left to right, line by line. So here we've got n equals 1, and we've got two spots already filled. So we'll call that 1s2. And similarly, we could draw the orbital diagram, right? We have the 2 electrons already filled. After that, we're done with that line. So then we need to go to the next line. So now we're at n equals 2, and we've got both of our S blocks filled, right? So that'll be our 2s2. And then after that, we can see that we're still at n equals 2 because we're over here. So we're still at 2. But now we're in the P block area. So now we're at 2p. Remember, at 2p, there are 3 orbitals there. And then we can think about how many electrons are here. Well, 1, 2, 3, and then oxygen would be number 4. So there are 4 electrons there. And again, we can draw the diagram. Remember, 1, 2, 3, they all go by themselves, all facing the same directions, generally up, although that's not a hard rule. And then we need to then, after that, double it up. And then we're out of electrons, right? So you see, just read this periodic table like a book, line by line. Let's think about fluorine right next to oxygen, and think about those electron configurations, right? So first off, we have the 1s1, then the 1s2. So we have both of those filled. After that, it'll go the 2s. Both of those are filled. Right, we're going to keep going until we reach our atom. After that, then we're going to go over here to this section. That'll be the 2p. Remember, there are 3 of them. And then we count 1, 2, 3, 4, 5. 2p, 5. And again, when you're drawing the diagrams, all 1 in each of the orbitals before doubling up, they all have to face the same direction at first. And then you double up, 1 down, right? So there we have 1s2, 2s2, 2p5 is the electron configuration of our noble gases. Or my bad, of fluorine right here, not our noble gases. All right, so let's take a look at chlorine next. So chlorine is right under fluorine. So again, we just count from left to right, line by line. So there's our 1s2. I'm just going to do the electron configuration, not the orbital diagram for this one. Then after that, 2s2. And after that, 1, 2, 3, 4, 5, 6. And that's the 2p. So 2p6. And now we're all the way down to n is equal to 3. We can see both of those spots are filled. So 3s2. And then 1, 2, 3, 4, 5. So that's 3p5. And there's our electron configuration for chlorine. As you can see, when we kind of get down here, this is going to get very, very, very long, right? And it's going to be a pain in the butt to write out. And so what we can do is use our noble gases as of a bit of a shortcut. So our noble gases are these guys over here. And they're very stable, so we're just going to use them as a shortcut. So you always want to use the noble gas above the element that you're looking at. So in this case, we're taking a look at chlorine. So the noble gas that we're going to use as reference is neon. And so if you think about where neon is, it covers all of this, right? All of this right here. The 1s2, the 2s2, and the 2p6 can all be written as just neon. And then we can just write 3s2, 3p5, right? So this neon represents all of the orbitals that are filled for neon, and then we can add some more to get to chlorine. If you notice, things in the same row will have very similar electron configurations, right? So we did neon, and we did chlorine. We also did fluorine. So with fluorine, we came up with as helium, right? I don't have to write 1s2, I could write helium instead, and then 2s2, 2p5, right? You see how it's S2 and then P5, S2 and then P5, right? Things in the same row will have very similar electron configurations. Let's take a look at bromine right over here. Again, we're not going to bother writing everything out. So what we're just going to say is we can just use argon as a reference, right? It's got all the same electrons that argon's got, and that'll basically take care of all of these rows, right? That's covered with this argon in brackets. Then after that, we just have to keep writing, right? So again, this is n equals 1, n equals 2, and now we're at n equals 3, and now we're at n is equal to 4, and then we just read it left to right, line by line. So that right there would be the 4s2. And then after that, what you'll note is now we get to the d orbitals, and they're all filled. Remember that the d orbitals are n minus 1. So instead of this being 4, it'll only be 3. 3d, and then if you count the amount of elements there, there's 10 of them. And then finally, we get over here. Now we're back to 4 because we're in the p block. So 4p, and then there's 5 electrons, 4p5. So through the use of a periodic table, this should be pretty simple, but really the key here is practice, practice, practice.